What is the native VLAN? Trunk ports send and receive Ethernet frames tagged with IEEE 802.1q VLAN tags. The primary idea behind this is to be able to transport frames from multiple VLANs over a single physical link between switches. This means that both ends of a trunk will always receive tagged frames as shown in Figure 1. But is it always? What if there is a hub in the way or any other Layer 1 device? What will happen if an untagged frame somehow gets into the trunk link? Native VLAN has been introduced to solve this specific scenario. Native VLAN is configured per trunk port. It is locally significant, and it tells the switch, if you receive an untagged data into this port, forward it like it is part of the native VLAN number. For example, if we configure the native VLAN on a trunk to be 20, if data without IEEE 802.1q header comes in that port, it will be forwarded in VLAN 20. You can see an example of this in Figure 2. PC7 is somehow connected to the trunk and is sending untagged frames. When they are received on both sides of the link, they are forwarded into the VLAN 20, the native VLAN. By default, the native VLAN of all trunk ports on Cisco switches is assigned to VLAN 1, but it can be any valid VLAN number. There is another very important angle to this concept. The switches are not only putting the received untagged data into the native VLAN, but they are also sending the data in the native VLAN untagged. Look at the example in Figure 3. The frames from VLAN 10 are carried across the trunk with 802.1q headers, but the frames from VLAN 20 are carried across untagged because VLAN 20 is the native VLAN of the trunk port. All control plane messages, such as CDP, VTP, and DTP, are also sent through the native VLAN, i.e. untagged. Native VLAN Mismatch interface. Trunk configuration is locally significant. This means that the trunk settings on one switch port do not have to exactly match the settings on the other side of the link. Therefore, you can configure native VLAN 10 on one side and VLAN 20 on the other side of a single trunk link. This causes a dangerous faulty state called Native VLAN Mismatch. Cisco proprietary protocol CDP can detect this misconfiguration and report with error messages as shown below. Please note that if CDP is disabled on the link, there is no way for the switch to automatically detect this. Native VLAN mismatch can cause some major issues and security implications, such as misdirected traffic. Frames originating in the VLAN configured as native are sent untagged across the trunk. Upon receiving on the other side on the link, they are forwarded in different VLAN because trunk settings don't match on both sides. VLAN hopping. Malicious traffic can cross VLAN boundaries